Hey guys, yesterday I gave you a quick introduction to dihybrid crosses using the slideshow that was posted in Canvas. And with that slideshow, I sort of wrote out everything for you to try to understand how dihybrid crosses work. And then hopefully, most of you were able to go in and watch the Amoeba Sisters video that sort of explained how dihybrid crosses work. So today, what I'm going to try to do for you is break down dihybrid crosses a little bit more, just in case you need a little bit more help with this. Um, and I'm going to use what we would probably consider to be more of a real world scenario just to help you see how these crosses are actually used in real life. As you know, most people could purchase a dog breed from a breeder if you so choose. Sometimes dog breeders will breed dogs for various reasons. Um, and we all know that sometimes there are dog breeders who breed dogs specifically for certain looks. You know, if you think about labs, labs can be yellow and different variations of yellow. They can be chocolate colored or they can be black. And so, what I'm going to do is I'm going to use a dog example just to show you how a dihybrid cross might actually relate to something you could be familiar with. So, let's say for a minute, we have two dogs that we're going to breed. One of the dogs is a male that has brown eyes and solid fur. The other is a female that has a green eyes and has spots. So what we're going to do first, I'm going to go ahead and open up a text box here, and I'm going to give you some information that you're going to need to know about uh, the dog's traits. So we know that brown eyes are dominant to green. This means that brown would be represented, let's go with the word I by a capital E, and green would be represented by a lowercase e. That means in order to get that green eye recessive trait, remember you must have a lowercase e or a green allele from biological mom and also from biological dad. We also know that in these particular dogs, solid color fur is dominant to spotted fur. So that means we're going to say solid fur will represent with a capital F, and spotted fur will represent with a lowercase f. So here's our two traits. Keep in mind that according to Mendel, the law of independent assortment was a law that he says states that there are some traits that are independent of each other, meaning when the alleles are kind of thrown out randomly through sexual reproduction, those alleles have no ties or association to each other, so they are sorted out randomly. And so when you saw yesterday in the practice that I gave you, when we did what was called the FOIL method for math, you saw that those traits were all independent of each other. And so you got several combinations because there was no connection between the two traits that were listed. So the traits for eye color and the trait for fur in this example are completely independent of each other. Okay? So what we're going to go ahead and do now, I'm going to open up a new box and I'm going to put a little bit more information for us right here. And in this information, I'm going to tell you a little bit more about the parents. So we have a male dog, and that male dog is homozygous for brown eyes. And also that male dog is heterozygous for solid fur. And we have the female, and what we know about her is that she is a green-eyed spotted dog. Okay, so that's our information we have to go with, which means what we can do now is we can set up these alleles to correctly represent what each of our dogs are. So we're going to start first with our male. If our male is indeed homozygous for brown eyes, that means the only genotype that dog can have for brown eyes would have to be two capital E's. Homozygous means the same, and the eyes are brown, which is the dominant trait, so it has to be two capitals. The dog is also heterozygous for solid fur. Now, the only genotype you can get if you are heterozygous is a capital. Oops, let me do an F, a capital and a lowercase for the fur. So this is the genotype here for our male dog. Now, our female dog, the information that we have on her is that she has green eyes and she is spotted. Now, from what we have here, we know that the only way the dog can be green-eyed is it has to have the recessive genotype. The only way the dog can be spotted is it has to have the recessive genotype. So that means all of our letters here have to be lowercase. The trait for green eyes would be two lowercase e's, and the trait for spotted fur would be two lowercase f's. Okay, so now let's present a question. You know, when some people are breeding dogs, they're trying to get sometimes a specific look. So our question is, would there be any puppies in this litter that could potentially have green eyes and be spotted? That's the question our dog breeder has. So the dog breeder is looking at this male and female and is going to try to determine whether or not any of the puppies in the litter could also be green-eyed and spotted if we mate these two dogs. So what I'm going to do for you right now is remind you of how we incorporate the FOIL method from math. Remember, FOIL stands for first, outer, inner, last, and that's how we can come up with our various genetic combinations that we can then put into this 4x4 Punnett square. We're going to start first with the male dog. So what we're going to do is we're going to take the first traits, or the first allele, for each of the traits. So the first alleles here are the capital E and the capital F. And that is one of our possible combinations. Let me make sure I designate this for us. Then we're going to take our outer. Our outer is this capital E and the lowercase f. Our inner is going to be a capital and a capital. And our last, give us some more space here, is going to be our capital and our lower. Okay? Now for our female, we're going to do the same thing. Now most of you probably already noticed that we have all lower cases here. So that means our only combinations are going to be 4 versions of a lowercase e and a lowercase f, since that is our only possibilities there. We're then going to put these combinations into the Punnett square. So normally what I've tried to be very consistent with you on this. Whatever the first parent is that's shown, I usually put the first parent at the top, and I usually put the second parent on the side. Keep in mind, it doesn't matter which way you do it, your results will still come out the same. So I'm going to place capital and a capital here. And I'm going to place the heterozygous genotype here, this one here, and this one here. Keep in mind, I got these combinations from the male up here. Then I'm going to put our females combinations down here. Okay. Now, for some of you, you can look at this already and you can probably tell whether or not you're going to end up with any combination in the middle that's going to lead to green eyes and being spotted. Some of you can see that immediately. Some of you may not be able to. So what we're going to do is we're going to work through this Punnett square to put together these combinations. And interestingly enough, while I'm doing this, my dogs are in the room with me deciding to fight with each other. I guess they don't like this example very much. So what we're going to put in here is we're going to combine. We have here and here a capital and a lower, an E, And here we have a capital and a lower. Notice I normally put the capital letters first, and that's because we are accustomed to reading and writing with capital letters coming first, and so that's technically the correct way to write it. In this box, again, we have a capital and a lower, and then we have two lowercase f's. In this box, we're going to have a capital and a lower, and we have a capital and a lowercase f for fur. And in this box, we have a capital and a lowercase e, and then two lowercase f's. Okay, one more time, if you're not sure how we got that, I took the E here and the E here. I took the F here and the F here to put together this box. And then I did the same for these two, and for these two, just like you read a graph. So then I would do the same thing here. I would take the capital E and the lowercase e here, and then I take the capital and lowercase f. Again, this time I have two lowercase f's. And here I've got a capital and a lower, capital and a lower. And here I have a capital lower and two lowercase f's. Okay, and then of course I would continue doing this until I finished up. You probably are noticing a pattern. This pattern is easy to notice mainly because all of these combinations here are exactly the same. So it makes it a little quicker for you to pick up on that combination. So what we're going to look at now is we're going to analyze what we've put together in this Punnett square. It looks like the only combinations we've gotten in this Punnett square are capital E and lowercase e, capital F, lowercase f, or we got the capital lower e and two lowercase e's. So what we need to do now is figure out what are each of those combinations, and does it meet the question that I asked you earlier? Are we going to get any puppies in that litter that could potentially have green eyes and be spotted? Okay, so according to this genotype here, the heterozygous for eye color means that it's going to have brown eyes. Can't spell brown. And heterozygous for fur means it's going to have solid fur. And it appears we see that trait several times on here. We're going to talk a little bit more about the ratio and all in just a minute. For this particular trait, once again, we have heterozygous for eye color. So that means it's going to be brown eyes. This time we have two lowercase f's, which means we will get spotted fur. But notice there's no possibility of any of the puppies in the litter having green eyes. All the puppies in the litter would end up with brown eyes because there is a 100% chance probability of those brown eyes. Okay, so let's talk a bit about our probabilities here. What I want you to notice is that all of the combinations in this column, I'll go ahead and highlight them for us. All of these combinations are all the same. That's the brown eyes and solid fur. And also, these are brown eyes and solid fur. So out of the 16 boxes, that's 8 of them, which means we have a 50% chance probability of puppies having brown eyes with solid fur. And then, of course, the other 8 boxes, or the other 50% chance, belongs to puppies with brown eyes and spotted fur. And let me just make sure I said that correctly. This would be brown eyes with solid fur. These would be brown eyes with spotted fur. So there's a 50-50 chance of each happening, which means every single time a puppy is born, there is a 50% chance of brown eyes and solid fur, or a 50% chance of brown eyes and spotted fur. So I hope that this sort of helps you understand a little bit better. Just always keep in mind that the traits are independent of each other. And really, the toughest part of this out of everything is just making sure that you are looking at the letters correctly and that you don't accidentally write a capital in the place of a lowercase or a lowercase in place of a capital, because as you can see, that would completely change your outcomes, and then it could lead to incorrect answers in the long run. By the way, if you do need any additional help with this, if you just find that you're very confused, please, please, please let me know. You can send me an email and I'll be glad to try to help you out. I know that this week's been a little bit crazy with map testing and shortened class periods. I still wanted us to be able to cover this, and I honestly feel like you guys can do a good job pretty much understanding this without too much assistance from me. So if you see that this is just going well above everything, please let me know so that way we can go back over some more before we get into incomplete dominance and codominance.